Okay, let us look at the ventilation parts here. Okay, ventilation. So what is the meaning of ventilation? Ventilation basically means that the exchange of the air between our lung and the atmosphere, so the oxygen can be exchanged for the carbon dioxide in alveoli. Okay, so this is the definition. So what is the process? So in order to achieve this ventilation, we must have inhalations and exhalation. So what is the mechanisms of the ventilations in our body? Okay, so very simple thing here. It depends on the pressure change. Okay, so what we do know, look here, look at this. During the inhalation, so our diaphragm actually, okay, the muscle, the smooth muscle they control the diaphragm, cause the diaphragm to move down. When diaphragm move down, look at this. This is our thoracic cavity. Initial. Now become like this. So can you see that there is increase in the volume? Volume increase. When volume increase, pressure decrease. Can you see that? Okay. At the same time, our rib cage also move outwards and upward. You try to inhale the air, you can see the rib cage move upwards due to the intercostal muscle contract. When the intercostal muscle contract, it will bring your rib cage upwards, outwards, and upwards. So further increase the volume. Okay, so diaphragm, and then you can see that our rib cage move outward and upward. And because of this movement upward and outwards, increase against the volume, further increase the volume. So make the pressure in the thoracic cavity actually lower than the atmospheric pressure. So atmospheric pressure higher, thoracic cavity pressure lower. So the air now can enter into the lung. So this is during the inhalation. So, okay, so two things happen here. First, diaphragm move down. The rib cage move upwards and outwards. So both processes increases the volume of the thoracic cavity. So when the volume increase, pressure decrease. So when the pressure decrease, therefore the air, okay, an atmosphere have higher air pressure compared to thoracic cavity, the air enter into the lung. So how about exhalation? So same thing. Now diaphragm move back to the original position. Intercostal muscle relax. Therefore, the rib cage now go back to original position. Okay, so move downward and inward. So what is the volume? Volume of thoracic cavity now? Smaller. When volume smaller, pressure higher, therefore force out the air. But the forcing out the air also depends of this elastic fiber that available in our alveolus. Okay. So what you need to do now, you complete the passage below by using the given term. So during the process of inhalations, okay, so in the lung, so the lung volume expands, okay? So why the lung volume expand or thoracic cavity, okay, expand as a result of the contractions of the diaphragm? It's not really diaphragm contract, but the muscle that control the diaphragm contract and also the intercostal muscle, okay? So when these two contract, what happens? It will cause the expanding of the thoracic cavity. Okay, so the thoracic cavity expand. So due to this increase in the volume, so the pressure now decrease. Always remember, okay, when volume increase, pressure decrease. Okay. Okay, so based on the principle of Boyle's law, so the decrease of the pressure in the thoracic cavity relative to the environment make the cavity pressure less than atmospheric pressure. So it creates what we call the pressure gradient between the atmosphere and the thoracic cavity, allow the air to rush into the lung. So inhalation process. So during the process, the chest will expand out and away from the lung. Are you clear? So moving upwards and outwards. So that's why we need to have the pleural cavity. If without pleural cavity, the movement of this rib cage is going to damage our lung. Okay. So exhalation is more to the passive process because muscle relax. So upon exhalation, the lung will recoil. In fact, it's not the lung that recoils, but the decrease in the thoracic cavity, okay, the volume. So the intercostal muscle now relax, return the chest wall into the original position. During exhalations, the diaphragm, the muscle, the contract diaphragm also relax, so moving higher into the thoracic cavity. Okay, so this increases the pressure within the thoracic cavity relative to the environment. So the air now rush out of the lung due to the pressure gradient. So the process is passive because the relaxations of the muscle, okay, and no muscle actually contracts to expel out the air. So we base on what? We base on the pressure difference and also this recoil of the elastic fiber. Okay. So if you want to measure the ventilation change, we can use this apparatus known as the spirometer. Okay, and we can record it in this what we call the chymograph. So what's a chymograph? So this is where the drum. Can I see that this drum? This drum actually will rotate, will revolve. When it revolve in a certain speed. Are you clear? So as long as we know the distance, we can actually measure the time by using this chymograph. Are you clear? So it's something like the wave, okay, that we record. So what happened here is, so this fellow can actually breathe out the air. So when you breathe out the air, so the air will enter into a chamber with carbon dioxide absorbent soda lime to absorb the carbon dioxide. So try to imagine and breathe out the air, absorbed by soda lime. So the air enter into this, okay, chamber. So in this chamber, you have the platform. This platform attached to the something like a pen or something like a writer here. So because we exhale out the air will fill out the chamber. So when air fill out the chamber, so this drum will move up. So it can record. Can I see that? And then when inhale, so when inhale, so the air from the chamber will be taken in. Okay? And then respiration take place, move out. So when we take in the air, then you can see that this chamber will move down. So it give up and down, up and down, up and down. So if you want to measure, we can actually measure few of the important, what we call this parameter by using this spirometer. So what are the important parameter? So this is the chymograph. It's an example of chymograph. So the lung volume roughly about 6 liter. Okay, the lung is about 6,000 ml or 6,000 case of 6 liter. But normally we use always here at rest. So this is called tidal volume. It's the normal air that we breathe in and breathe out at rest. Are you clear? It's a normal tidal volume. We don't actually force in or force out the air. But if let's say I purposely, okay, I force in the air, take in the air until maximum. We try to take in. So when until maximum, so this one is termed as the, can you see that? Inspiratory reserve volume. So means that this is max that I can go. Okay, until maximum. Okay, so this arrow a bit wrong. So it's a bit until here only. Okay. So again, guys, start from here. There's the arrow move out already. So start from here. The peak of the white and the tidal volume go up. Take up. So means that we take in the air and then forcefully. So that's for inspiratory reserve volume. Take in the air. Okay. Or you can release the air. So release until the maximum that we can release. So this volume is called expiratory reserve volume. So we have inspiratory and expiratory reserve volume. So means that if you move in an air and decrease the air, so this total, can you see that? Inhale the air, exhale the air, the total here is termed as the, so again, it's until here only. This one move up down here. So this one is termed as the vital capacity. Vital capacity means that's the capacity that allows us to move in and out the air. Okay, so we have total lung capacity. So the remaining one, guys, the remaining one is termed as the residue volume. Okay, residue volume. So means that you won't be able to force out all the air, no matter how, if no, your lung will collapse. Are you clear? So we have certain volume of the air to maintain the lung. So this one we call residue volume. So in our syllabus, we only need to know one, tidal volume. So why we need to know this tidal volume? Still remember when during the exercise, we increase the breathing rate, correct? And we take in more air. So the tidal volume actually will increase. Okay, during exercise, tidal volume increase. Are you clear? Because we breathe in more air. Okay, so now based on the description just now, fill in the blank. Okay, so assume that you guys have done already. So now let's look at this. So the volume of air that it moves in and out each breath during normal rhythmic breathing. So normal in and out. So this one is called tidal volume. Okay, tidal volume is the one that we need to know. Okay, so the volume of air exchange after a forced inspiration followed by the forced expiration. So it means that you inhale to the max and then release all. So in this case, it's known as the vital capacity. Vital capacity. So additional air, okay, volume air that can be taken in after a normal tidal inspiration. So only normally take, right now. So this one is the inspiratory reserve volume. Inspiratory reserve volume. Now, the additional air that can be forced out after a normal tidal expiration. So you, okay, release, but release even more. So this one is the expiratory reserve volume. So the remaining air in the lung that cannot be expelled out even though we force out, but you still can't. So in this case, this is termed as the residue volume. So out of these 5, the only one that you need to know is the tidal volume. Why? Because tidal volume can change based on our activity. If vigorous activity, tidal volume will change. Okay, so the rate of supply of O2, okay, to the cell is determined by the rate and the depth of your breathing and heart rate, which is a pulse rate. Okay, so breathing rate. What's mean breathing rate? If a breathing rate defines the number of breath that we take in, okay, a breath that we take in within a set duration of time, typically in 1 minute. Are you clear? So breathing rate. So for example, you sit down, you time yourself. 1 time, 2 times, 3 times. So this is what we means by the breathing rate. Okay, so breathing rate only do counting. We don't talk about volume. Okay, so the breathing rate, we do counting only. Nothing to do with volume. But if you want to know the volume, then we go for the ventilation rate. Are you clear? Okay, be careful when you use the term. Breathing rate means that you increase the breathing. How many times? Are you clear? For example, before exercise, maybe 30 times in 1 minute. But now you increase to 45 times in 1 minute, for example. Okay? So ventilation rate is defined as the total volume of the air move into the lung in 1 minute. So total volume. So in this case, what we need to do here is we need to calculate it as the product, means multiply the tidal volume and breathing rate. So ventilation equal to the tidal volume multiplied with the breathing rate. Are you clear? So it will give us, because tidal volume will be in dm cube or cm cube, breathing rate is per minute. Okay, so therefore ventilation rates will be dm cube per minute. Okay, so the unit. So let us look at this question. Okay, so figure 7.20 show a chymograph of a 17-year-old male with a mass of 70 kg who breathed normally, took a deep breath and then breathed out as much as possible. Okay, so you can see that in this case, It's a bit opposite. Okay, you can see that now. The platform that show us, the chymograph show us the decrease. So means that breathe out the air, breathe in, breathe out, breathe in, breathe out, breathe in, breathe out, and so on. Can I see that? Okay. So for every two divisions, indicate 5 seconds. Okay. Can I see that? For every two division, 5 seconds. For y-axis, every 4 division is 1 dm cube. Okay, so first of all, if you want to calculate ventilation rate, okay, how to calculate ventilation rate? I think I need, guys, sorry. So I add another page here, easier for me to do the calculations. Page. Okay, so now, what is the duration of time, guys? What is the duration of time at A? So we calculate. So for each, for every 2 division, okay, so the time taken equal to 5 seconds. Can I see that? For every divisions, right? For every 2 divisions, so the time taken is 5 seconds. So what is the duration of A? Okay, what is the duration of A? So if you count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Clear not? It's 24. Are you clear? Okay, so it's 24 divisions. So 24 divisions divided by 2 divisions. So durations multiplied with 5 seconds. So total, you see that is 60 seconds. So equivalent to 1 minute. So means the duration of A, no worry already, is 1 minute. Clear not? Okay, so now next. In this case, if you want to calculate the ventilation rates, yeah, let me show you guys. So now we do know, first of all, in order to calculate ventilation rate, so we need to go use the tidal volume multiplied with the breathing rate. So if a rate means that the time, so means that what is the breathing rate? So breathing rate in this case can see that how many breathe in and breathe out during this. So from here, 1 time, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times. So breathing rate will be 12 per minute. Can you see that? What is the breathing rate? 12 per minute. 1, 2, 3, 4, 5. So what is the tidal volume? If you look at tidal volume here, tidal volume, how many? So for every guys, can you see that? For every 4 divisions, equivalents to 1 dm cube. So now 2 divisions, cannot. And enlarge it. Can you see 2 division? Half box to half box, half box to half box, 1 division, half box to another half box, another division. So the tidal volume, can you see that? The tidal volume. Okay, so what is the tidal volume? So 2 boxes, correct? Okay, so let us calculate. So for every 4 divisions, and the y-axis equivalents to 500. Is 500 or 05? So 1 dm cube, sorry. It's equivalents to 1 dm cube. Correct? Okay, so means that's what is the tidal volume. Tidal volume, you can see that is 2 out of 4 multiplied by 1, so you get actually 0.5 dm cubes, or the tidal volume. So what is the ventilation rate now? So ventilation rate will equal to tidal volume 0.5 dm cube multiplied with the breathing rate throughout, okay, per minute. So the answer here will be 6.0 dm cube per minute. This is the ventilation rate. Clear? So every time there is a decrease. So why decrease? So you can see that every time inhale, decrease, inhale, exhale, inhale, exhale. At the end, you can see that there is a decrease. So the decrease is due to the CO2 release but absorbed by the soda lime. So we only check. You don't need to add one by one here. If you add one by one, it's difficult for us to see. Can you see that? How much? You don't know. But we can take the cumulative every time. 5, 5, 5, 5, 5. Toward the end, you can see that. So it's 1.5 divisions. Okay, so volumes of CO2, okay, are equal to 1.5 division out of 4 division. Each division is 1 dm cube. So calculate, give me the answer. 3 significant figure. In 1 minute, okay, volume of CO2. 1.5 divided by 4, multiply with 1. So answer is 3 significant figure, 375 dm cube. So total 0.375. Okay, can I see that? So this is volume of CO2 consumed, release. So volume of CO2 release in 1 minute. So equal to 0.375 dm cube. Okay? Can you see that? So this accumulation. So the first one, the first time the effect may be 0.1, 0.05, then 0.01. Is it 0.05, 0.1, 0.15? Why? Because every time they accumulate a little bit. So this bit by bit, you accumulate at the end, you can see the overall effects here. So this decrease is due to the CO2 release, but absorbed by soda lime. If you don't have a soda lime, what will happen? If you don't soda lime, you will get back the same. It won't change. It won't decrease. Can I see overall? You can see the decrease, but it won't. If let's say we remove the soda lime. Okay. So any more questions? If no, I have done for this topic.